In this lecture, that is mathematical logic, lecture number 5, we are going to study the compound statement, double implication or biconditional. The symbolic representation for this double implication or biconditional statement is P, then you have a double-headed arrow that is on both the sides, Q, where P and Q, these two are simple statements. P and Q are simple statements. P and Q are simple statements, and when you write this double-headed arrow in between these two simple statements, P and Q, you call the statement formed, the compound statement formed as biconditional statement or double implication statement. This is biconditional statement or double implication statement. I shall write the definition for double implication or biconditional. So here I write, if two simple statements, P and Q, are connected by group of words, if and only if, by group of words, if and only if, or IFF, then the resulting compound statement, is read as, P if and only if Q. It is read as P if and only if Q, and such compound statement is called as biconditional or double implication statement. So here is the definition, students, for you all. As per the definition, you can check here. If two simple statements P and Q, there are two simple statements P and Q. These two statements are connected. They are connected by a group of words if and only if. You are connecting these two words with a group of words. You are connecting these two statements. Which statements, students? P and Q, which are simple statements. You are connecting them with the help of group of words if and only if, which is in short also written as IFF. Then the resulting compound statement, if you do that, you will get compound statement. Simple statement, you are combining them with the group of words if and only if, which is symbolically written as this. This is the symbolic representation. What is that? It is double-headed arrow. Okay. So you get the compound statement. And what is that compound statement read as, called as? It is read as P if and only if Q. P if and only if Q. That is the way you read it. Like if you remember in the lecture number 4, I wrote P, then arrow Q. So how did we read it? We read it if P then Q, if P then Q. So this one you read it as if P then Q. And here, if you have two arrows in between P and Q, how you read it? You will say P if and only if Q. And such compound statement, what is the name of this compound statement, students? It is biconditional statement, or you can call it as double implication statement. Okay, now I give you an example for this. Okay, let's have an example. For example, suppose I have P here. Suresh is hardworking. Q, Suresh will win the gold medal. Suresh will win the gold medal. So students, if I write here P, then double implication Q, okay. So what statement will I get here? Symbolically, if I write P double implication Q, P if and only if Q, then it will be Suresh is hardworking. Suresh is hardworking if and only if and only if Suresh will win the gold medal. This is how it will be. I hope this is clear to you. Now, next we are going to see the truth table of double implication statement, the truth table. So here I make the truth table. Truth table for double implication statement or biconditional, whatever. Biconditional Now students, as you all know, when I say a truth table, why is a truth table important? A truth table is important because a truth table gives us the truth value of the compound statement for all different possible truth values of its component statement. So here I will write P and Q. Here I'll write P double implication Q. So a truth table, why is the truth table important? Because a truth table gives us the truth value. It gives us the truth value for the compound statement for all different possible combinations of truth values of component statements. That is why the truth table is important. So let's do it. All different possible combinations of truth values. So here T, T, TTFF, as you know, and here I will write TTFF, and here we shall write TF. Now this gives me the all possible combinations of truth values. This gives me all possible combination of truth values of P and Q. You cannot have any other than this, 4 possible combinations. Now when P is true, Q is true, then here it will be true, double implication, true. When P is true, Q is false, then true, biconditional or double implication, false. In the third case, it is false, double implication, true. And the fourth one is false, double implication, false. Now remember students, in these two cases, which two case? The first one and the fourth one. What you notice? You notice that both the statements, you need to understand the law, the underlying law you have to understand in order to remember the truth table. For any compound statement, the law, the underlying law is very important. If you understand the law, the truth table becomes very simple for you, or else you will struggle. So learn the law. See, the law says here, when both the statements in a double implication statement or a biconditional statement, when the two statements have same truth value, they have same truth value. See, true, true, they are same truth values. False, false, they are same truth values. Remember, they are same truth values. Then the truth value will be true. And in other cases, it is false. See, if you remember it this way, you will remember. Otherwise, you will get confused. You just cannot remember by mugging it up. True, double implication, true, true, double implication, true, double implication, true is true, true, double implication, false is false, false, double implication, true is false, false, double implication, false is true. This is not the way. You cannot learn it. You have to learn the underlying law. You have to think over it. What is it? When the truth value of the two statements in a double implication statement is same, if they are same, true, true, both are true, same, false, false, both are false, same, then the truth value is true. And the other cases, it is false. I hope you have understood this. So students, let's write the law, the underlying law which prepares the truth table for double implication statement. Law. The law is, in a double implication or biconditional statement, in a biconditional statement, let me write biconditional this time. In a biconditional statement, when the truth values of component statements, what do I mean by component statements? P and Q, these are component statements, and this is compound statements. So in a biconditional statement, when truth values of component statements are same, they are same, then the truth value of biconditional statement is true. In other cases, the truth value is In other cases, the truth value is false. So students, what did I write here? I wrote when the truth values of component statements are same. See, true, true, same. So it is true. False, false, same. They have P and Q, they have same truth value. So true. In other cases, when the truth values are not same, then it is false. You can check. Okay, so this law you will have to learn. Now we go to the next. Let's solve few problems, students, based on this. Let's solve few problems. So here I have the problem. The question is, write the symbolic representation of the verbal statement. They give us a verbal statement, we have to write the symbolic representation. So write the following statement in symbolic form. There is a question. Write the following statement in symbolic form. So here we are given the statement here given is, there are several. I'm solving this is question number 1. There are several. I'm solving the 4th one. And it is, milk is white. Milk is white if and only if. So students, what is this? This is connective. This is connective. If and only if. Which connective? It is double implication connective. If and only if milk is white, if and only if the sky is not blue. The sky is not blue. So students, we understand if this is connective, then this one and this one here, these two are the simple statements. What are they? They are simple statements. So these are two component statements or simple statements which is connected by the connective, biconditional or double implication. So I have to write this whole thing in a symbolic representation. I have to write this in a symbolic representation, this whole statement. Okay, this whole statement I have to write in a symbolic representation. So what I will do, students, I will take this as P. This one, I will take this component statement, I'll write it as P, and this one as Q. And I know what does this stand for. This stands for this symbol. So I will get P double implication Q. That's it. That will be my final answer. So let's begin it. Such questions are asked in exam. So I'm giving you an illustration for this. So I will write here the answer. I will write, let P be milk is white and Q be the sky is not blue. So then I will write, therefore the symbolic representation P double implication Q. P double implication Q. Okay, students, we are going to write a very important statement here. This important statement you will all understand and learn it. The truth value of a compound statement, the truth value of a compound statement. What does that mean? It means it could be negation, it could be implication, it could be double implication, conjunction, disjunction, whatever it could be. The truth value of a compound statement depends on two things. Depends on, number one, the truth value of its component statements, truth value of its component statements. Second, the connective used for the compound statement. These are the two facts which will decide the truth value of a compound statement. If you are having a conjunction here, suppose this compound statement, you are having a conjunction. I'm sorry. You are having a conjunction. So the connective is this. So this connective will decide, along with the truth values of P and Q, what will be the truth value of that compound statement. So that's what we saw in all the truth tables. This is a very important statement which you will all understand and learn. Let's solve few problems, students. So here the question says, find the truth value of each of the following. So here I have two questions. We have to write the truth value of these two statements. And remember, these two statements are compound statements. See, the first one is, it is not true that 3 minus 7i is a real number. It is not true that 3 minus 7i is a real number. So students, you can check here. 3 minus 7i is a complex number. It is a complex number, as we know. So in order to write the truth value of this, we can go as follows. What I do here is, let me hide it. Let me hide this not. Now read it. So it becomes, it is true that 3 minus 7i is a real number. See, the moment I hide this not, the things have become so easy. It is true that 3 minus 7i is a real number. The statement says it is true 3 minus 7i is a real number. So here, if I'm asked to give the truth value of this statement with not hidden, I will say it is false. Why? Because the statement is saying it is true, this is real. I know it is true, this is complex. So it is false if not is not there. If not is not there, it is false. So with not, what it will be? It will be true. So here I write the truth value. I write here the truth value of above statement is true. That is, I'll write capital T. Okay. Now, I hope you must have understood. Read the next question. The next one is, if a joint venture, if a joint venture is a temporary partnership, if a joint venture is a temporary partnership, then discount on purchase is credited to the supplier. Okay, now students, we all know that a joint venture is actually a temporary partnership. So this thing is true. This thing is true. Okay, and we all know that discount on purchase is never credited to the supplier. Discount on purchase is debited to the supplier. So the next one is false. So here what we have, we have here true. The first one is true, and here if I call this as P, then P is true. If I call this as P, then P is true, and here if I'm calling this as Q, so it is false. So here I have if P then Q, if P then Q. So it is P implication Q, that is true implication, or true implies false, and you know the law, if true implies false, then it is false. So the truth value of this is false. What is truth value of the second statement, the second question? It is false. So if you want, you can write this solution as follows. Let me help you out writing the solution of this. So I can go like this. I will write here. I'll write here. Let, see, I'm writing the solution for you. Let P be a joint venture. I'm writing this one. See, after if, and before then. So if a joint venture So what is P? P is a joint venture. P is a joint venture. That is after if. After if whatever I have, this is my P. After then whatever I have, that is my Q. So I write a joint venture is a temporary partnership. And Q, I write it as discount on purchase, discount on purchase is credited to the supplier. Now here I'll write, students, P is true, okay, Q is false. P is true, but Q is false, okay. And what was this statement, the whole statement, the whole given compound statement? It is P implies Q. It is P implies Q. P implies Q. That is, true implies false. Why? Because P is true and Q is false. That is, true implies false. So what will be the final answer, students, here? The final answer you will write, the truth value of above statement is false. True implies false is false. So the final answer will be the truth value. I hope you can write that on your own. You will write the same, the way I wrote the answer for the first one. You will write for the second, the truth value of above statement is false. Don't write true, write false. And this is it. Okay, I hope you all have understood. You can see the things once again. So the next question here we have is, we have to write the truth value of this given statement the way we did the earlier two problems. Neither 27 is a prime number nor divisible by 4. So students, you see this is a conjunction statement. It is a conjunction statement, that is, it is it is conjunction statement, that is we got and in between. So how do we have and here? That is a matter of discussion. So as it says, neither 27 is a prime number, neither 27 is a prime number nor divisible by 4. So here I write this as, I will write let, so my answer begins from here. I write let the statement P be, I write here 27 is not a prime number. 27 is not a prime number. And then Q I write 27 is not divisible by 4. Now listen students, while writing P and Q, I'm using not. I wrote P as 27 is not a prime number. I wrote Q as 27 is not divisible by 4. The reason was it is neither nor. That is, neither it is this nor it is this. Neither it is a prime number nor it is divisible by 4. 27 is not a prime number and 27 is not divisible by 4. So you can write a statement using neither nor, or you can write a statement like this. You can write a statement like 27 is not a prime number and 27 is not divisible by 4. Both will be equivalent. I repeat what I said. I said just now, either you write the statement as the given, neither 27 is a prime number nor divisible by 4, or you can write 27 is not a prime number and 27 is not divisible by 4. Both are equivalent. So here, students, having written this, now I write the truth value. So what is truth value of P? The truth value of P here is, P is 27 is not a prime number. So truth value is true, because we know 27 is not a prime number. What are prime numbers? Those numbers which have the factors as 1 and themselves. 27 has factor as 3, it has factor 9. So definitely 27 is not a prime number, it is true. Okay, then we have Q. What is truth value of Q? 27 is not divisible by 4. That is again true. This is again true. So symbolically now you see here, this statement is P and Q. As I told you students, the given statement, you can write P and Q. So it will be P and Q. So P and Q, that is true and true, which is, true. So the final answer, what you will write students? The final answer you will write as the truth value, you will write, therefore the truth value of above compound statement is true. I hope you must have understood this. Students, now you can pause the video and solve this 5th question here. Okay, take the help of the 4th one and solve this 5th one. Pause the video and try solving this on your own. So let's have one more question here. In this, what we notice is there is a question where we are given if P and Q have truth value true. See, it is written very clearly, if P and Q are true and R and S are false. It's given that R and S are false. R and S have the truth value as false. Find the truth value of following statement. We are given the truth, we are given a statement and we need to find the truth value of this this particular statement, under the data that P and Q have truth value true, R and S have truth value false. So this is the compound statement. So I start writing the answer for this. So I would write here P implication Q. P implies Q. So this is true implies true in a bracket. Then here I have double implication, negation, and I have true, disjunction, true. That is true or true. Next step, students, we all know that the law of implication says, that true implies false is only false. True implies false is only false. In all other cases, it is true. So you can all understand that how important knowing a law is. If I know the law, the things become so easy for me. If I know a law, the things become so very easy for me. So here the next step I will write as this is definitely true, then double implication and negation of true, disjunction, true. Now see, I know the law for disjunction. The law of disjunction says that if both the component statement have truth value false, false or false is only false. If false or false I have, if I have both false, then only it is false. In all other cases, it is true. So definitely true or true will be true. So this is also true. The next step I have true, double implication, negation of true is false. So the final one I have true, double implication, false. Now once again I have here double implication. I know the law of double implication. The law of double implication says when the truth value of both component statements are same, when the truth value in double implication, the law says when the truth value of both component statements are same. See, true, double implication, true, 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 both are same. False, double implication, false, 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 both are same. So when both the component statements have same truth value, then it is true, and in all other cases false. So definitely it is not the case here. I do not have the truth values the same. This one is true, this is false, so this is definitely false. So the final answer is false. For the given compound statement, the truth value is false. I hope you have understood this. If any doubt, you can again see the whole thing. Okay students, now we have another question where we have to solve a problem which demands as follows. The question says, assuming that following statements are true. We are given Sunday is a holiday, P is true. We are given P is true. Then Q statement is Ram does not study on holiday. Ram doesn't study on holiday. Q is true. Find the truth values of the following statements. Now we are given a compound statement. You can check students here. We are given a compound statement. See, what is compound statement? Sunday is not a holiday, or Ram does not study on holiday, and there is a connective or. So I understand that the given statement is a compound statement which comprises of P and Q, maybe negation P or negation Q, whatever, that we will have to check. So what I do is, in order to find the truth value of this given compound statement, I would first write this given compound statement in a symbolic form. So I will go ahead as follows. So see students, here I write here the above compound statement. This is very important. You all need to understand and learn this part, because if you understand, if you learn to write this thing which I'm writing now, if you learn to write the given compound statement symbolically, then the things will become very simple for you. Okay, the above compound statement can be written symbolically as follows. So see, how do I write it symbolically? Sunday is not holiday. Sunday is not holiday. I will first write this as Sunday is not holiday. Students, Sunday is holiday is P. So Sunday is not holiday. It will be negation P. So here I write negation P for the first part. Then I have or. So since I have or, I will write disjunction. Then I go for the next after or. It says Ram studies on holiday. Now students, Q says, the statement Q says Ram does not study on holiday. So what I have here is exactly opposite of what Q is. Q says Ram does not study, whereas this says Ram studies. So what will this become? This will become negation of Q. This is negation of Q. Now what I'll do is I will substitute the given truth values to me. So as it says that P and Q both are true. It has been already stated that the given two statements are true. So I would write here negation of true, disjunction, negation of true. So this will get me here false or false. And as you know students, the law says when both are false, disjunction is false, so that is false. So I got the truth value as false. I hope you all must have understood. If not, then again you play the video once again. Several times you can play and learn this. Now we go for the next one. The next question is if Sunday is not holiday, then Ram studies on holiday. Okay, I have to write the truth value of this. So once again, my answer will begin. What will be the answer? I'm not going to write the statement once again. If you are writing, I would request you to write the statement. And what will be the statement? This thing you will write once again. The above compound statement can be written symbolically as follows. So that part you will repeat here. The above compound statement can be symbolically written as follows. And then you will write the symbolic representation here. Okay, so I'm not going to do that. I will write directly the symbolic representation. First of all, what I understand students here is that the given statement here is an implication statement. What kind of statement is this? This is an implication statement. Why? Because I have here if then, if this, then this. Okay, so Sunday is not holiday. Sunday is not holiday. Now students, Sunday is holiday is P. So this Sunday is not holiday will become negation P. It will become negation P. Okay. So if this, then this. Now you understand, I will have an implication sign here. As you all know, I will have an arrow. Why? Because we always know if something, then something. So if something then something, then it is always this implies this. This implies this. So negation P implies. And what is this? Ram studies on holiday. Students, Ram does not study on holiday is Q. So if Ram studies on holiday, it is negation of Q. Negation of Q. Now I write the truth values as I was given. I was given the truth values. I will write those truth values. So here, what would I get? I will get here negation of true implies negation of true. Negation of true is false, implies false. The law says if true implies false, then only false. In implication, what is the law? True implies false is false. Elsewhere, always true. Learn the law. That's the smart way of doing the problems. If you know the law, you know everything in mathematical logic. You should know the law of truth values of all these compound statements. So false implies false is true. The answer is true. Okay, now we have the next question. The next question is, I write the answer for you for this also. Sunday is a holiday and Ram studies on holiday. I would request you all to pause the video at once, write the answer for this. Once you have written the answer, come back to the video once again to check whether you have written is right or wrong. So Sunday is a holiday. Students, Sunday is a holiday was P. If you remember, Sunday is holiday is P. So here this is P. Okay, then and is conjunction. Ram studies on holiday. Ram studies on holiday. Ram does not study holiday. Ram does not study on holiday was Q. So Ram studies on holiday will be negation of Q. After having written symbolically the given compound statement, I shall now put the truth values that I was given. So P was given to be true, and negation of true. Q is also true. So what I have true and false. And you know, students, the law says in conjunction statement, when both are true, then only true, otherwise false. So the final answer is false here. I hope you all must have understood. Practice all these questions again. Practice all these questions once again. Thank you.